under their science department. Trevor Nace is the contributor. Trevor Nace is a writer. He is also a geologist, I believe. He received his PhD from Duke University. Studied geology and the climate of the Amazon. He's the founder of Science Trends and a Forbes contributor. Trevor Nace. Harvard scientists begin experiment to block out the sun. Harvard scientists begin experiment to block out the sun. I want to thank Patrick for sending me this. Trevor Nace. A group of Harvard scientists plan to tackle climate change through geoengineering by blocking out the sun. The concept of artificially reflecting sunlight has been around for decades, yet this will be the first real attempt to control Earth's temperature through solar engineering. The project, called Stratospheric Controlled Perturbation Experiment, or SCOPE-HEX, will spend $3 million to test their models by launching a steerable balloon in the southwest U.S. 20 kilometers into the stratosphere. Once the balloon is in place, it will release small particles of calcium carbonate. Plans are in place to begin the launch as early as the spring of 2019. The basis around this experiment is from studying the effects of large volcanic eruptions on the planet's temperature. In 1991, Mount Pinatubo in the Philippines erupted spectacularly, releasing 20 million tons of sulfur dioxide into the stratosphere. The sulfur dioxide created a blanket around Earth's stratosphere, cooling the entire planet by 0.5 degrees Celsius for around a year and a half. As scientists, governmental agencies around the world, and environmental groups grow increasingly worried of our collective ability to reduce greenhouse gas emissions and curb climate change, the idea of geoengineering a solution has become more accepted. The ultimate goal is to reduce the warming on Earth. This can be done by reducing greenhouse gas emissions, sucking CO2 from the atmosphere, or limiting the sunlight that reaches the Earth's surface. The first two methods are actively discussed and implemented to various degrees. The recent commitment of G20 members, with the United States as the sole rejecter to the Paris Agreement, will act to solve the source of the problem by reducing greenhouse gas emissions. Sucking CO2 from the atmosphere and locking it away in Earth's crust, called CO2 sequestration, has been implemented and deployed. For instance, Royal Dutch Shell has built large carbon sequestration facilities with the Canadian and Australian governments. The third method, blocking out sunlight, has been controversial in the scientific community for decades. The controversy lies in the inability to fully understand the consequences of partially blocking out sunlight. A reduction in global temperature is well understood and expected, however. There remain questions around this method's impact on precipitation patterns, the ozone, and crop yields globally. This is precisely why the Harvard research team intends to spray tiny chalk particles, calcium carbonate, into the stratosphere in a controlled experiment. Computer models can only go so far in predicting the impacts this geoengineering technique Computer models can only go so far in predicting the impacts of this geoengineering technique. Boy, I keep finding typos doing this. The word "of" is missing here. So computers can only go so far. It is time for a real-world test. With funding in part by Microsoft co-founder Bill Gates, the Harvard team will begin to answer the remaining questions as early as the spring of 2019. That's next year, folks. While the potential negative effects are not fully characterized, the ability to control Earth's temperature by spraying small particles into the stratosphere is an attractive solution largely due to its cost. The recent Intergovernmental Panel on Climate Change, IPCC, report estimated that the continual release of particles into the stratosphere could offset 1.5 degrees Celsius of warming for $1 billion to $10 billion a year. Now, so this is assuming that the negative effects are not somehow filled with problems. When comparing these costs with the global reduction in fossil fuel use or carbon sequestration, the method becomes very attractive. Thus, scientists, government agencies, and the independent funders of this technology must balance the inexpensive and effectiveness of this method with the potential risks to global crops, weather conditions, and drought. Ultimately, the only way to fully characterize the risks is to conduct real-world experiments, just as the Harvard team is embarking upon. Pro-science Trevor Nace is a PhD geologist. There you go. We're going to block out the sun. We're not going to be worried about the consequences of that behavior, though. Thank you, Patrick, for sending me that interesting and fascinating piece from Forbes magazine by Trevor Nace. You are watching the AntiClimactic NonShow.